this is what our partitions look like. So for each one of these partitions, we have specific imagery that we've collected, and we have metadata about each scene within each one of these partitions. So 57,000 of those squares covers the globe. They're about 6,000 square kilometers. The feature polys are the metadata about that 30 to 60 centimeter imagery that's in there. And when you drill down into the actual metadata partition, each one of these polygons is a scene that we're showing in Maps API, and it has associated attributes, the metadata, vintage, resolution, whole ton of other ones we won't need to go into. 54 unique in all, a ton of it. So we have a bulk tiler system that basically goes out. It grabs imagery from the factory based off of what I tell it to, and it tiles out that imagery from zoom levels 13 through 19 and creates one of those partitions, 3857 JPEGs for Slippy maps. The metadata is also included in each one of those partitions. It's actually zipped up. It's a shapefile that's zipped up and dropped into that partition, each delivered as a tar ball, right? Not quite compressed, it's just a block of data delivered to S3. So on S3, each one of those tars delivered to a bucket, specific prefix, and then the tar ball. So what we end up with on S3, and this is a product of process that we have in place, the digital globe, is we end up having 57,000 directories on S3, each one of those with one tarball in there. So you start to see the, how do we pull this all out and make sense of it into one global data set? And with tars, there's no central directory. There's nothing that you can access that says this is what you're going to find. It's actually stored sequentially in blocks. So you start at the beginning of the tar, you read, the first block tells you what the next few blocks are, and then you have another one that tells you what the next few blocks are. So you can only read them sequentially. The potential, remember, that imagery is stored in that partition. It's possible that if we were to try to read every single tar on S3, we would actually open up 10 gigs of imagery before we actually get to the metadata. That would just blow it up, right? And S3 can handle it, but it's a massive waste of resources and time. Here's the idea. Why don't we just run a script that reads tars on S3 and copy them over to a different location? But there's two problems to solve with that. You have to find a way to actually stream the tar into a pipeline so you can read the data without actually reading the imagery. And we're actually able to solve that because we have process in place with how we stored the metadata zip inside there. It actually ends up at the very beginning of every single tar. Totally lucky, completely lucky. But no documentation exists online that we could find about how you stream tars out of S3. How do we build it? How do we do it? This is where Node.js comes into the rescue. And my crack developer, John Saints, is the one that did this. I cannot claim any ownership of doing this. I'll just be forthright here. So instead of running a script, we're going to run an app that's going to read those tars, copy the metadata zips to a different location. This is going to be repeatable, it's recursive, it's stable. So simple, product manager can do it, right? That's awesome. All right, so Node.js. So basically what it does, it accesses that S3 bucket and the individual prefixes. It locates all the tars and all the tars in the subsequent prefixes, so if they're buried, they can find them. It's going to write a list of those tar objects to a specific file, which is objects in bucket, and then it reads that file, refers to it, and for each object listed in that file, it'll read that tar sequentially, find the metadata zip, which just so luckily happens to be stored in the very first few blocks of each tar, eliminating the need for us to open up the imagery, and then copy it into a temp directory. And then close the tar file, move on, and do the next one, right? So I've actually put this, I guess you'd call it code base, up on my GitHub. It's called tar S3 extract, and it has everything you need there. And you can actually plug in your own environment keys for your access tokens, your secret access tokens, where your S3 bucket is. So you have dependencies that are listed, the list of the tar objects, that's where it writes the list out of the app. It's got your JavaScript code, and then the command that actually runs everything. and then your environment setting where you put in your own keys. So basically, this is an app that you can use to extract, read tars on S3, stream them into a pipeline, and then the delivery location where all those zips go to. Then, of course, our node libraries. So it's there. The next step is now we've got all those zips in one directory, right? 57,000 of them. I just went the simple route, and I just use an OSX tool because I had it. Maybe I do Python next time, but for now, all I did is I just went in and used the OSX unzip utility, and it unzipped it. And then it removed all the unwanted zips. But the problem is that when it did that, it created 57,000 directories on my local system, right? So now I still have that problem, but it's a little bit easier accessible data. Let's just move all the shapefiles in those unzipped folders into a working directory. Say what? Wait a second, shapefiles, it's not just one file, right? Silly shapefiles, we got at least 4, maybe 5 or 6. So now we got to do some redundant scripting in order to make this work, to access all the shapes, drop them, all the DBFs, drop them SHX. Like I said, I apologize. For those of you that are really technically deep, you're like, oh, we could have done this. Well, I didn't know how to do that, so this is my story, right? So, Python. And luckily, our shapefiles has some sort of naming convention that's consistent across all of them. And it's simply, capital letters, shape. All the names, for all 57,000 of them. So, using that naming convention, thank God for process, we could read the directory and list all the file names, the same characters, meaning shape, star dot star, and copies that to a specific directory. This is how we get the data out of the latest data jail and into one location. It's simple Python, 2 different utilities, and then it prints all done. Makes you feel good when you're done, right? So, QGIS. Now we've got all the shapes in one directory. We want to get them into a mosaic. Simple vector menu, data management tools, merge shape files to one. Let's let it crunch, get a beer, coffee, whatever you need. Uh-oh, that's not going to work. It's not because of QGIS. Shapefile, DBFs, we have a 2 gigabyte limit. We've got 57,000 shapefiles with 54 attributes in each, 117,000 features. Can't do it. All right, let's go back to the drawing board here. Let's divvy up our shapefiles into regional mosaics, not a global mosaic. And the naming of our partitions, we could actually go through and identify those that are in the United States, those are in Western Europe, those are in Russia, so on and so on, to divvy them up into regional mosaics. So just by the naming convention, we could split up and then, using QGIS, build the mosaics of our shapefiles. So now we'll have 5 different mosaics instead of 1. So there we go, merge shapefiles into one. We're doing well. We got our shapefiles into 5 different regional mosaics, but they're still huge, 54 attributes. 117,000 features to cover the globe. That's 117,000 images that cover the landmass of the globe. Someone had a bright idea. Let's use our private GitHub to share this data, right? It's great. We can share between teams. We can allow for automation of the entire process. And the updates can be managed. We can have multiple resources doing the updates, not just the product manager, right? Sad Michael again. We can't do that. Not quite. File size limitations in GitHub. Makes sense. I totally get it. It's the right approach. We just have too much data. 100 megabytes maximum. How do we get that down? Well, at the same time, someone else had a bright idea. Let's just send a vector data bomb up to Mapbox. Let's see if they can handle it. Create a vector tile set. It'd be awesome. Single update for the entire globe, right? This is not Mapbox's fault, right? It's just that, and it makes sense with vector tiles. 260 megabytes is the data limit, and you start getting into maximum tile sizes at maximum resolution. It's just simply not possible. It's not a matter of not being able to do it. So we thought, what we should really do is we should probably remove the fields that aren't necessary to consumers and commercial. Let's narrow it down. So we started with 54 attributes. We went to 6. We need our unique ID for troubleshooting. We need to know what sensor. We need to know the formatted date. It's a nice date. Whether it's a mosaic data or it's a metropolitan area or if it's just strip imagery that happen to meet our spec. And of course, the ground sample distance, which is number 1 or number 2 most important attribute that people want to know. And then age of the imagery, which is the number 1 attribute. How many years? So by doing that, we went down to 6 attributes. Obviously breaks down or compresses the storage quite a bit. Now we're down to regional features, which are manageable, but we went from something that we knew was at least over 2 gigs to 360 megabytes total, but the largest region was only 98. So now we're underneath that 100 megabyte limit for sharing internally. So if we can share internally using GitHub and we can also upload it into Mapbox, it's a full-on win-win situation. We're happy. Now let's move forward. And this is the part where my dog turns 5 this week, and I just wanted to say happy birthday, Coco. I love her. She's awesome. All right, so we've got those regional mosaics up there, the metadata, all right? And we want to create 5 different Mapbox tile sets. So let's tile these suckers. So we use the Mapbox upload API. Find it on GitHub. You do have to have Node.js installed. And you have to have a Mapbox secret token with a specific write scope enabled. And so 3 simple commands, we loaded all that data up there. We uploaded the Mapbox, or installed the Mapbox upload. We wrote our Mapbox access token to the environment. And then we basically used the upload API to designate a username and data ID. And for us, it's digitalglobe.us Western Europe metadata, right? Something simple. And then the path to the file, our regional mosaic. Pro tip for you, if you're doing this, just make sure that after you're done uploading your tile set, you go back in and set your tile set to public because it automatically defaults to private. And so what that means is if you happen to do an update and you got a map out there and then you update the data, if the data is private, then no one can see your map. So now that we've got them tiled, let's style them. So we go into the Mapbox Studio, create a new style, and we based ours off of satellite streets. You could also base it off of a light-based map, your choice. But we started with that because of where the labels were. And I'll get into that in a minute. So in Studio, it's actually pretty easy. I was using Studio Classic Desktop for a while, but I'm getting further and further into the online version, so I'm pretty stoked on it. You just create a new layer and layers from your data, which is your tile set. I apologize, it's kind of hard to see, but we have right here, this is where one of our color cache metadata for one of the regions is located. Simple. You just select that, and then we make sure our zoom scales are set. So one of the things that happens with global metadata is that your metadata isn't available all the way at scale 0. It might only be available starting at Z3, maybe Z4. So we have to account for that. So then we add a filter. And this is where we say, hey, we got attributes stored in this data. Let's style it based off the attribute. In this case, the first style we want to do is, what's the imagery that's less than a year old? Age years equals 1. That's what we did with our data set to cut down on the file size. Put in our filter. And then what we get returned here, a nice map in the United States, these are all the polygons in our metadata that are 1 year old or less in our imagery. And then we create the layer. We start to style it because we want to add some color to it. That's the whole point of this. We want to show different colors for different vintages. So we take that layer, and then we basically apply that type of filtering on the data set to not only US and Western Europe, we do it for, rest of world east, which is Far East, Central, which is like Africa and Northern Europe, or Northwest Russia, I guess you could say. And then we have a West one, which is Americas minus USA. And then they have a nice button inside the Studio Classic. It's really hard to see, but it's duplicate. So once I built that once for one year, I can duplicate it and then just change the styling and the filters, and saves me some work and redundancy here. So from there, I created one for 2 years old, 3 years old, 4, and then anything older. And then I make sure I rename it and I publish it. And we've got global metadata tile sets. So we use Mapbox GL, the JavaScript version, for publishing our styles. And then we also put our maps up on JS Fiddle for our API documentation, so people can actually see the code. They can add it to their own application. That's the whole point of Maps API, is that it's application agnostic, and we want to put everything out there so you can just grab it, move it, add it to your application, and move on. And this is the output of what we end up having here. So we have, it's a basic vintage metadata map, but it's telling you a story. All the blue is 2015, 2014, 13, 12, differentiated by color, and older. So every time we update, we hope to make this map more blue, more dark blue, I should say, than anything else. And our customers can come to this and either see it, or they can add it into their own application as an overlay on top, so that question is eliminated. When was this imagery collected? So now that we're done, we're going to have some beer, we're going to hang out and talk about the story that we just went through. But there's room for improvement, because this was really a first pass for us. You know, I'm trying to figure this stuff out. I'm doing my best. We want to automate this from end to end. Don't want to do all these manual steps, right? So, you know, basically automating from Node.js and then into, basically want to have an automated process to get the data out of jail, get it extracted, pulled out into one location, and then even automate the QGIS processing, so that it's almost kind of easy button, right? I understand that it introduces error at some point, but we'd like to try that. Obviously replace that OSX utility with Python, and then the Python basically, you know, the bundle, put the extract all with the output to one directory all in one instead of 2 different steps. We want to increase the metadata detail, and this is important. So yeah, colors are good, but I think really what we want to do is go with outlines so that you can still see the imagery underneath. A time date stamp at Z16 to Z19 or 20, excuse me. So something like this, where you have the imagery boundary, but your vector tiles are drawing the outline of the metadata and clearly states when it was collected and even the time. That's the level that our commercial customers want. And of course, increase scale availability. So I'd like to have the metadata available at scale 0, so I can zoom all the way out to the globe and show it in one holistic view for people to understand how recent is our imagery really. And then I'd like to be able to build a smart Mapbox GL app, which our users can go in and actually identify on the pop-ups and possibly get more than just 2 metadata attributes. And so just to see this in action, I'm going to try this out here. This is what we have up on our API documentation. So we have our vintage map, and then we also have a resolution map as well. And the resolution map is basically detailing, is it 30 centimeter, is it 40, 50, or 60? So we want to go a little bit further, and the colors are way off on this screen, by the way. I'm not that bad of a cartographer, I promise. But the idea is to give more and more information. Like I said, it's a first pass, but we're pretty excited about what we've been able to do so far with it. So that's it. Hopefully that was good. We got like 5 minutes left. Happy to take any questions or comments or concerns. Thanks. Thank you. Thank you. Yeah?
Is there a particular reason you went with Node for that chunk of logic, or just familiarity?
The question is a reason why we went with Node to solve the problem of streaming tars out of S3. It really was familiarity, and it was also the skill level of the developers that I have available. They felt very comfortable, and that's what they wanted to do, and that's how they solved it. Any other questions? Awesome. Well, thank you very much for attending. Appreciate it. Have a good one.